claw battle. And oh my God, I've been battling with this issue for quite some time. And to be honest, I don't think there's a um, straightforward solution to this. This is something that I realized you can't just brute force your way into it. This is actually, this has to be like, this has to be built in order to solve the problem that I'm describing right now. It has to be, how should I say that? Like, you'd have to really groundify your fixes and have fully blown revision controls, have uh, concrete vector based analysis for every single um, thing, every session that you introduce. And when you start building any kind of open claw type of related projects, or heck, not even open claw, could be anything, you start running into complexities. Now, those complexities are, um, they could get really, really complex. Like there's certain complexities can get really, really complex. And when that happens, like all hell breaks loose. Any kind of cron jobs that you created before, anything that you um, were trying to do before becomes basically really hard for you to debug and to troubleshoot and decipher. For like, for example, when dealing with the gateways, what I do is I figured, hey, let me write a quick recovery protocol that kind of solves the problem of fixing a gateway. And then later, I realized, wait a second, I need to add something extra. I need to add something extra into the gateway so this way it can kind of restart one extra other service. And the minute you begin doing this extra, the minute you begin combining that something extra, is the instance you're introducing kind of a technical depth, technical depth, and the result becomes well, it becomes convoluted, and all of a sudden the gateway doesn't work. No, and you could be throwing like lots of money into it trying to solve it, and still you could be really like fighting with it and just spend like a lot of money just trying to troubleshoot it. So, uh, one thing I realized that like the only way out of this problem is to create virtualized environments. Meaning, if if you run OpenClaw locally, that's all good and great. It's in the beginning. Is this China? This China? No, no, no. This is America. This is I live in Connecticut, not so far away from New York, not so far away from Manhattan. But today I figured I talk about OpenClaw, OpenClaw and my struggles, my trials, my triumphs, and tribulations. Woohoo! Yeah. So guys, keep those questions coming. But yeah, today was really like a breaking point for me because I realized I realized how much technical depth I managed to introduce. I introduced so much of that technical depth that it was basically impossible for any kind of model to solve the chaos that I created. And this is when I realized, like, man, uh, AI kind of, I mean, no matter what you try to introduce, you're going to need to kind of build everything in a groundified way, isolated way, with a virtual machine for almost pretty much any kind of open claw instance that you run. Because what happens if you just kind of run it on your computer locally, everything is good and great, but at the end of the day, what's gonna happen once you start introducing like an extra heartbeat, an extra watchdog, an extra something, it becomes like your open claw just becomes um really dumb. It becomes kind of it just looks like complete madness, guys. If you don't virtualize everything that you do with OpenClaw. Now, I could talk about a couple of techniques that you could solve the problem with the gateway and do all that. Um, the best thing I could recommend, guys, is like obviously start off everything with semantic search with Obsidian Vault, everything groundified in Obsidian Vault in a NAS storage while having solid state disk access to your OpenClaw. So this way you could do everything super fast, but have synchronization constantly taking place from your solid state disk where all those scripts are running from, everything's running smoothly. You want to be replicating that to your local storage NAS drive. So this way you could connect to it from your iPhone, from your other laptops, your personal laptops, and so this way you have constant um, memory. So the other thing which you want to do is you want to have virtual machine. You want to run everything inside of a virtual machine. So this way, if for whatever reason you get cooked through all of those, like Git revision controls, and just when the whole open cloud just gives up on you, then you could roll back to a fully blown virtual machine snapshot. Because no matter what, like here's what happens, guys. In order for you to get the wings of freedom, in order for you to feel like you could just fly with this, in order for you to generate that, get closer to that super intelligence, you want to remove all the guardrails, pretty much everything, and just kind of fly with it across all those Git repositories without any kind of boundaries when you build things. But then, like once you get to a certain state, after you build it, you're gonna be like, damn, okay, I think it's a good version. I think now there's a good time for me to like have a more groundified version uploaded to GitHub, and also at the same time you want to make it available to as a full virtual machine image. So this way you could have this kind of golden image um, to jump into. The problem with all of this is simply because like you always gonna here's the problem. The problem is there's infinite kind of thoughts in your mind for what you want to do next and next, and you never know like 100% certainty if you're complete or not complete, and when should be the golden image, when you should produce the golden image. uh, which is why you want to have some of those subsequent controls, subsequent heartbeats that are cross-checking, validating, and when they're validating everything, they need to be making that decision for you. When is a best time for writing something to local Git and synchronizing that to your NAS from your solid state disk, and when is the time to do so, when to synchronize to your GitHub, and when is it a good time for it to do the Git, to do the full snapshot virtual image. And the problem with that, like if you just have a bunch of agents kind of cross-checking things, and when they cross-check and check on you, they become out of state. They become kind of like the cohesiveness goes out of the window. Um, so like the way I see that you could solve that problem is, sure, you could have like feudal educator Clay, central orchestrator to go to consult, where your agents can consult and execute. So this way there's like central brain. But for you to be able to get to that brain and to be able to just smoothly operate without everything going down the drain like crazy, in order for you to be able to do that, you need to think in variable layers where you introduce each, like let's say you're dealing with a static issue. Anytime you finish with that static issue and realize that this there could have been a better way of doing it and more dynamically. This is when your brain need to be like connecting to it and making that decision for you from on the fly through synthesis constantly as you do so. So this way you develop dynamic based infusion and vector based thinking in your second brain. So to pull this off, you really need, in when it comes to emergent properties and when it comes to measuring and introducing sovereign protocols and decay protocols and cylindrical and spherical kind of embedding, in order to like make the memory a lot faster. When it comes to doing all those things, remember you're introducing always different complexities. Um, there's a lot of folks in one of the universities in China that is kind of like equivalent to Harvard. They found a way for how to embed cylindrically, spherically, I should say, spherically. They were able to embed. I think it's called quantum sphere kind of binarization or something like this, where you embed all of your files into into this sphere, and to retrieve information faster. And there's lots of use cases in finance for this. It's very good way of dealing with time series based data when you're dealing with that. So obviously, like wow, it's called Chronos if you guys want to look it up. But um, to pull this off, to be able to like build your own SQLite VSS with embedding and using Minimax 2.7 model to kind of to reduce the tokens, to pull this off and be able to like constantly stack on top this intelligence, you really need to have this multiple memory contexts solved. That problem needs to be solved. It needs to be like you need to have vector-based storage, um, and of course, like typical RAG. And of course, you need to tap into this other time series-based use cases. Now, some of you will say, "Well, I don't have a time series-based use case." Well, then make one. Convert your data into time series use case. So this way, you could express everything in terms of time, dimension, and space. And the more and more I think of physics and all sorts of other things, does AI make you nervous? Um, no, AI. How should I say it? AI actually, yes, it could make you nervous, like if it doesn't get stuff done. So like you could end up becoming a victim of that if you get cooked and addicted. So yeah, yeah. So anyway, that's my discoveries of OpenClaw. I'm probably gonna like I'm super close of just wiping out all of those protocols that I built and just revisiting the entire process and building everything on a VM environment. Super close. Um, but there's also limitations with that. Super close, yet not close enough. Maybe I'd want to do this in a containerized based environment where I just run a bunch of containers in localized Docker and have OpenClaw connect to it, and obviously have the guardrails and RAG with um, embedding running on on entire NAS drive, but doing it in a way where it's a lot faster while utilizing solid state disks for any of those extra jobs without getting cooked. So I think that's going to be the next thing. But like grasping this, attempting to grasp this, and attempting to do this in a fast, hyper fast way is almost impossible without introducing solid state architecture. You, it's not even a speed related kind of issue. Um, it helps. Speed helps, but it's not really a speed related issue. It's more of a it's more of an issue where you just simply like don't have enough firepower to like mentally navigate through all those complexities. And of course, that's what I'm trying to solve. And um, hopefully that was beneficial for you. So keep enjoying those workshops, guys, and I'll see you next time.